Hey guys, I just remembered that when I was explaining this number one, when I was explaining number one, I didn't exactly explain why it was that we only had a U-stoic and not a BCA chart. What made the difference in the wording of the problem? So I'm gonna just real quick, just in like a minute or two, I'm gonna explain really quick. So when we look at the wording of the problem, the wording is, what is the percent yield of water if 25.6 grams of CH4 is combusted according to the following reaction and 45.0 grams of water is produced? So what this problem is saying is that it's asking, well, what we have to first calculate we've got to calculate the theoretical mass of our water that's produced after knowing the fact that 25.6 grams of CH4 was combusted. In other words, we're saying that we used up all 25.6 grams of CH4. It's gone. So that's how we know it's our limiting reactant. So we know that this has been all the way used up. And then because we know that's what's been used up, that's our limiting reactant. It doesn't really matter how much of this was put in. So that's why we were able to go from 25.6 grams of our CH4 into grams of H2O. It's because the word combusted here is telling us we used all of this up. We used all 25.6 grams of CH4 up. And the wording in number two as to why we had to do a BCA chart is because it's asking us what the percent yield is when we start off with 53.8 grams and 73.5 grams of the other stuff. So because it's just saying flat out that, well, you're mixing, here are the two masses of the things that you're mixing, what do you expect to find at the end? So because we're just thrown, what we're immediately putting into this chemical reaction, again, which would be the mass of substance A and substance B, so the aluminum are two reactants here, excuse me, we have to first figure out what is the limiting reactant, see how much of, and see that the limiting reactant is used all the way up, and then to find out after this has all been used up, how much is left on our product side, or how much was produced on our product side here. Okay, so again, here we know that this is a limiting reactant and we know all of it was used up, so we can simply just convert. Over here, this is all we begin with. We don't know what's been used up and how much of it will be used up, and we don't know how much of the excess reactant will be used up, which means we don't know how much will actually be produced or theoretically produced, and so that's why we had to make the BCA chart. Okay, hope this helps. If you still have any questions, make sure you get in touch with me, guys. If not, I will see you in the next one.